From the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, welcome to NASA's New Horizons Countdown to Pluto. I'm Mike Buckley from APL Communications and Public Affairs with the latest update from Pluto's doorstep as we count down to New Horizons' historic flyby of the Pluto system on July 14th. We're 14 days away from the Pluto flyby, just 2 weeks and only 10 million miles from Pluto. All the activities the team has practiced for years are happening for real. Now let's check in on some of those activities with an operations update. And we get to say hello again to Alice Bowman, the New Horizons Mission Operations Manager. Alice, thanks for stepping away from the console for a few minutes to join us on the show.
Sure, it's nice to be here.
We know that activity is picking up, right? Can you give us an idea from the operations team what's happening that indicates that we're really close to the flyby?
Right, so if you've been looking at the pictures on the website, you can see that Pluto and Charon are becoming more distinct in their surface features. It's getting pretty exciting, and every day is bringing new features into light. From the mission operations point of view, we've just transitioned to a set of commands that we actually started planning in 2011. This is called the Approach Phase 3, and this current command set will get us to July 3rd.
So these are the commands that are sent to the spacecraft's computers that essentially tell it what to do for a set period of time.
Yes, yes.
So you mentioned planning something for years in advance. Okay, in this case, 2011 for the load that's up on the computers now. I guess it really indicates this is not as simple as just writing a few lines of code and hitting a send button. I mean, especially for something like, this is a one-shot deal that things have to work. Take us through how you actually plan, design commands that go to the spacecraft.
Sure. So the science team has a set of observations that they want to accomplish. There's many of those that happen at closest approach, which is, of course, July 14th, but there are also many that happen on this approach phase. And the most intense observations are starting right now. Not that it hasn't been intense, but a lot of the group 1 and 2 observations are really gearing up right now. So to build a command set that goes to the spacecraft involves the science team, the guidance and control team, the mission design team, the navigation team, the mission operations team, the instrument analysts, all those people. And so that starts with the science team really defining what kind of observations they want. And then mission operations knows how to operate the spacecraft, what kind of constraints you have to take into account. We'll talk with the guidance and control. And so this is really like a dance. You have to have all those observations intertwined with the spacecraft commands. And again, we can't just take science. We have to turn and look to Earth and communicate with Earth and bring back that science data. So it's kind of a push and pull, like where you take science and where you turn back and communicate with Earth.
Of course, you mentioned communications. I know communications are critical, for these operations, and that's the connection between New Horizons and NASA's Deep Space Network. So maybe remind us a bit, how long is the one-way time for a signal to reach Earth from the spacecraft?
The one-way time is about 4.5 hours.
Get back here. Explain how you stay in touch with the spacecraft over such long periods of time.
So there are 3 DSN complexes, Madrid, Spain, Canberra, Australia, and Goldstone, California. And so if you think of the path our spacecraft New Horizons is traveling, it's going straight out to Earth, right towards Pluto. And the Earth, on the other hand, is rotating once every 24 hours. And as those different complexes come into view, you can use those antennas at those spots on Earth to communicate with the one that's in view of the spacecraft.
Now, I'll point out that people can follow that coverage online through DSN Now, the NASA website that allows people to see when each Deep Space Network antenna is either talking to or listening to any spacecraft anywhere. If I went to that website and check New Horizons, I might see 1 or 2 of those antenna stations talking to the spacecraft?
Yes, you'll see us communicating with the spacecraft when the spacecraft's not taking science. And so there's usually about 3 or 4 hours there in a period of maybe 12 hours where we aren't in communication with the spacecraft.
There's also some busier periods too, right? During the flyby, I think much of the Deep Space Network is going to be focused on New Horizons. Tell us about that.
Yeah, it's going to be pretty interesting. We have the radio science experiment, and what we do there is we uplink signal to the radio science experiment, and it will collect data like therm scan or occultation data. So if you were to go to that DSN site and look at those antennas, there's a total of 13 antennas. And 4.5 hours before closest approach, you'll see that New Horizons will be using 7 of those 13 antennas.
A busy day, busy morning.
Yes, definitely. And I'm not even sure there's been any other spacecraft that has actually used that many at one time.
Well, then speaking of busy, what's next for the operations team over the next week or so?
Well, we're going to be putting up the flyby sequence on board the spacecraft in the next couple days to both the primary and the backup computers. There's a possibility that we'll be doing a trajectory correction maneuver, and of course getting down lots of science data, optical navigation data. So it's going to be great.
All right, well, thanks, Alice. All right, now let's get a science update. We managed to pull Deputy Project Scientist Kathy Olken away from the images just long enough to tell us about some of the amazing views that New Horizons is getting of Pluto and its moons. So, Kathy, thanks for joining us again.
Happy to be here.
Our view of Pluto is changing dramatically, right? So, kind of what are we seeing now that we weren't able to see a week or even 2 weeks ago?
Yeah, there's features on Pluto that we were starting to see before, and they're coming into sharper and sharper focus. We see a bright region on Pluto's north pole, so it might be a polar cap. We're looking to get closer and investigate that further. We're seeing detailed images of the closest approach hemisphere. We can look every time it comes into view as Pluto rotates every 6.4 days. And you can see it getting larger and larger, and there's dark regions and bright regions, and it's going to be really exciting.
I mean, and that's the one we're going to see close up too, so it's just enough of a tease to get a preview of what you're going to see when you get close enough.
That's right. The science team spent a lot of time looking at when to fly by Pluto, which involved which hemisphere we would be seeing at closest approach, and we're all really excited that we chose this hemisphere because it ends up being really exciting.
Now, we're also starting to see details on Charon for the first time.
That's right. It's very exciting. We're seeing details on Charon. We see a dark region in Charon's pole, which is surprising to me. A lot of times on polar regions, you see bright features like we do on Pluto and Mars and Earth, where you have a bright polar cap. But this region is dark compared to the rest of the surface. And so it's very tantalizing and just waiting to get closer and see more about it.
Right, another mystery to solve.
That's right.
Happening here too. Something a little closer to your heart because you work on this instrument. The Ralph camera actually got some color readings of Pluto and Charon recently. And from those, we got our first New Horizons color movie.
Yeah.
Tell us a little bit about what was in those that we learned about Pluto and Charon, that we had some color views.
That's right. So we have a color movie of Pluto and Charon, and in it you can see that Pluto is distinctly red compared to Charon. Charon is more of a gray color. And you can see as Pluto and Charon are both rotating, that Pluto is more red on all the faces compared to Charon being gray. And so this confirms what we knew from ground-based observing, but it's giving us more and more detail as we get closer and closer.
And plus, it's just cool to see color.
It's really exciting to see color. Yeah, yeah.
Are they true colors in what we saw in that
They
movie?
are true colors. We've worked really hard to try and make them as close to true color that the eye would see. So that is a true color movie.
So it's definitely a busy time for the science team getting closer to Pluto. What activities are on tap for the next week or two leading up to flyby?
There are so many different activities coming up this week. We have observations of Pluto and Charon continuing as they get larger and larger. We get closer and closer. We've got photometry of the small satellites of Pluto. We've got color images. We've got infrared images. The plasma suite is busy doing its thing. It's a very exciting time.
That sounds like it. Well, Kathy, thanks again for joining us.
Thank you.
You know, it's probably safe to say that every member of the New Horizons science team loves Pluto, but probably for different reasons. So let's hear from another one of the real Pluto files.
I'm Fran Bagnall. I'm at the University of Colorado in Boulder. Back in, about late 1989 or so, there was a bunch of us who were really keen to go to Pluto. We wanted to have a mission that would get out there and make observations of this object right on the edge of the solar system. So we realized to make this happen, we had to get together and campaign hard to make the case to go there and explore. So it was a bit of an opportunity for young people to come in and say, hey, where are we going to go next? What's the next great frontier that we should go explore? And it was clear, out to the Kuiper Belt. Pluto is a very exciting place. It's right at the edge of the solar system. We've got a bunch of junk out there, and we don't know why it is there. And current ideas are that it got there through the formation of the solar system. And there's Pluto out there representing that junk, remnants of the formation of the solar system. When I started as a professional scientist, planetary scientist, there was Pluto, and it had this big exciting moon called Charon. And then we found another one and another one. We keep finding these moons, totally unexpected and a great surprise. So it'll be very interesting to see what we find when we get there. How many more are there? I actually think we have no idea what we're going to find. It could be completely different. You see these fabulous paintings that people have drawn of icy surfaces and clouds and mist and rocks and mountains. Could be completely different. Oh, the satisfaction of the whole mission will come when we see those first pictures and we actually get a glimpse of what that icy surface looks like. It really tells us about how our world, our solar system formed and how it got to be the way it is. So it's cool. Let's go there. Let's go explore it. I'm really hoping that we can conserve enough fuel on the New Horizons spacecraft that we can then use a little bit of extra power to change the spacecraft, deflect it a little bit and send it off to another object. Because I'm pretty sure that Pluto is one of a whole family of very different types of objects. Different colors, different ices, different histories, different gases. And it would be fun to go and see two, not just one. I'm Fran Bagnall, and I'm a Plutophile. And the reason is because Pluto is cool.
Now, as we're just 2 weeks away from the Pluto flyby, we thought it was a great time to cover the reason for the mission. That's why is New Horizons exploring Pluto, and what specifically is New Horizons going to learn? And to answer that is Bill McKinnon, a New Horizons co-investigator from Washington University in St. Louis. Bill, thanks for joining us.
Thanks for having me. It's fantastic to be right here, right now. I just can't even believe it's happening.
When Clyde Tombaugh first discovered Pluto, it was considered an oddball. But we've learned then, over the decades, that it was actually a harbinger of an entirely new class of planets in a new realm of the solar system. So kind of show us how the evolution of Pluto, how we got to how we think of Pluto today.
Yeah, well, as you know, Clyde Tombaugh discovered Pluto in 1930. And at the time, people thought it was the long-sought Planet X, the new world beyond Neptune. But it was odd. It wasn't as big as Uranus or Neptune. And in fact, no one could figure out how big it was at all. And it had this strange orbit. It wasn't with the rest of the planets. It had an eccentric loop that even took it inside the orbit of Neptune for a while during its course around the sun. And it really wasn't until the 1990s that we fully grasped where Pluto belonged, in a sense, what it was trying to tell us back in 1930. Because in the early 1990s, we used CCD technology, the kind of stuff we have in our cell phones now, and finally attached it to a telescope. And it's so sensitive that the first new Kuiper Belt object was discovered. I say new one because in a sense we now know that Pluto was the first Kuiper Belt body to be discovered in human history. And so now we know thousands of these bodies. It's the last 20 or 30 years of astronomical observations have really filled in what's going on. There's a whole new third zone of the solar system beyond Neptune.
Because we really are then venturing into a new realm, right? A whole new realm of the solar system. So tell us a little bit about that.
Well, if you think about it, in some ways, the Kuiper Belt is like the asteroid belt. The asteroid belt's inside Jupiter, the Kuiper Belt's outside Neptune, but there's 1,000 times more stuff outside Neptune. And the best part is that amongst all these hundreds of thousands or millions of bodies are big worlds, well, big in a relative sense. They're small planets. Pluto is actually the biggest of these, as far as we know, and there's several others. So it's an entirely new solar system in a way.
So tell us about that. We mentioned Pluto is, of all these objects in that region, in the Kuiper Belt, Pluto is the brightest, the biggest that we know about so far. So tell us a little bit more about what kind of, like, this new kind of planet that Pluto represents.
Yeah, well, if you look at Pluto, what you'll actually see is an icy world, but on the inside, it has a rock heart. And we think it's big enough and warm enough on the inside, we believe, that it could even have an ocean. And of course, it's not really alone. It has a big moon. In fact, it has 5 known moons. So it's a miniature planetary system.
I mean, you see those too. I think people are amazed at, when New Horizons launched, right, there were 3 moons that we knew about, 2 more since then. You start to learn a little bit more about what we can learn from a system like that. And there's some similarities. I think we've thought along the way that some similarities between Earth and Moon and Pluto and Charon and its other moons, even how they developed.
Yeah, and if you look in a book, sometimes you'll find the Earth and the Moon described as a double planet. But the Moon's only 1% of the Earth's mass. Pluto's moon is 12% of its mass. So it's the true binary planet in the solar system. In fact, when we watch it, as we approach it with the New Horizons cameras, we actually see Pluto and Charon both moving, both orbiting their mutual balance point, like a sort of asymmetric barbell. So in fact, that's one of the reasons, of course, we're studying it, because it's going to help us understand, really, in a sense, how our own moon formed.
So I mean, that the moon formation aspect of it is one. So let's specifically, what is New Horizons going to learn in the Pluto system? What's going to teach us about Pluto?
Well, we're going to learn so much I could hardly tell you all the things at once.
Let's do the mission goals. What are we looking to do?
We've actually set it up in a sort of hierarchy where there's stuff that's absolutely required to do, stuff that, you don't even have to be a rocket scientist to understand what we're doing. We're going to take lots of pictures, understand the global geology, understand what's on the surface, the composition, and that way we can infer what's underneath. And of course, Pluto, of course, is a very complicated world. It has an atmosphere. It's actually an atmosphere that's slowly leaking off into space. So we're going to probe this atmosphere in every way we can with our instruments and learn all about it, and learn about this fundamental process that affected actually the early Earth, atmospheric escape.
So there's different goals as the mission was laid out. Say what the science community really wanted New Horizons, any mission to Pluto and the Kuiper Belt, to learn. You mentioned there's different levels, different priorities. So there's tops on your list of what the mission needs to get, and then I guess it goes to another level below, and then levels below that.
Yeah. So I talked a little bit about what's absolutely required of the mission, and then there's just a lot of important stuff to do. It's important because we have the cameras and we have the technology that will take very high resolution pictures. We'll also take overlapping pictures, and that way we can get stereo and really learn the topography. And we can, of course, measure the temperature, not just in the atmosphere, but on the surface. In fact, we can do this 3 separate ways. It's fantastic. And not to interrupt, but if we keep going, there's even stuff that isn't required, it isn't necessary, it isn't as important, but it's desired. And that's things like looking for new moons or looking for rings. And basically, all of the things we want to do, we're going to do them all.
And it's a full slate. I mean, but you have this opportunity, and you have a great spacecraft at your disposal to get as much as you can possibly get on this one shot and the first time through the Pluto system. It looks like you're going for the whole list.
Yes, yes.
So you've been working on a Pluto mission for a long time and really looking forward to get here. Personally, what are you looking forward to the most? Learning at Pluto or just seeing in that Pluto system as New Horizons goes by in July?
I've been interested in Pluto my whole life, and I've been working on it scientifically since the early 80s. But what I'm most interested in, I suppose, are in fact the details of its geology and the geology of its big moon, because they could both be active worlds. And who knows, maybe there'll be clues there for what's on the inside, like an ocean.
And even just in a basic sense, just seeing it up close for the first time, right? I mean, just your ideas of what it might be, but then to really see it, it just has to be incredible.
Yeah, I mean, day by day, every image is just better than ever taken before.
So it's going to be a great ride. So I look forward to it. Right? Well, thanks, Bill. Thanks for joining us.
Oh, pleasure to be here.
A misconception of Pluto is that it's so dark. But really, for just a moment near dawn and dusk each day, the illumination on Earth actually matches that of noon on Pluto. Now, we call this Pluto time. And a cool NASA web program can help you find Pluto time in your area. It's always Pluto time somewhere, and NASA wants to see your view. Visit the Pluto time website, take a picture during your local Pluto time, and share it to social media with the hashtag PlutoTime. Then check the web to see if your view is among the most interesting shots from around the world. Now, of course, for the New Horizons team, with just 2 weeks to go until the flyby, it's really Pluto time. Now, this wraps up our weekly updates from Pluto's doorstep. We'll be back on July 7th to begin our daily live updates to continue through the Pluto flyby. So until then, I'm Mike Buckley from the Johns Hopkins Applied Physics Lab, and for the entire New Horizons team, thanks for watching.